Okay guys, so today we're going to be looking at differentiating trigonometric functions, right, or trig functions for short. Now for the purpose of add maths, right, the CSEC add maths, when we do differentiation of trig functions, we only do sine and cos, right? If you're doing it at the Cape level, or you're doing it for Cambridge, they would also have tan for Cambridge. Cambridge Add Maths will have tan. And if you're doing it for pure maths, you would have a few more trig functions that you would have to differentiate, right? But just excuse that noise. Okay, so I don't know if you realize that I paused the video, but I did. So like I was saying, if you're doing the add maths with CSEC, you only required to know sine, the differential of sine x and the differential of cos x, right? And then, you would use that with other rules to solve problems or differentiate bigger functions. So if we have y is equal to sine x, the differential of that is cos x, right? So differential of sine is cos, differential of cos is negative sine, right? So I'm going to show you how you're going to use these two basic formulas to work out some bigger questions, right? So if you look at question 1, we have sine of 3x squared plus 2, right? And we want to differentiate that. Now, what we can do is use the chain rule, right? So with the chain rule, whatever is in the bracket, we would normally let it be. You could choose whatever letter you want. I like to use T, right? So you can let that use T. If let that be T. If you cannot remember the chain rule, you could just go back to one of the previous videos that we dealt with that, and you could look at it, right? Before we go into it, we also did a shortcut to the chain rule to solve questions quicker, right? So what I'm going to do is I'm going to work out this question using the chain rule the long way, and then I'm going to show you a shortcut that can help you get the answer faster and would worth the same amount of marks, right? And then as we go on to the other question, we'll use the shortcut. But for the first example, I'm going to go through the long way and then the shortcut. All right, so we need to get a substitution, right? Because remember, with the chain rule, you have to get a substitution, which is normally the part inside the bracket, right? So this would be t, right? So we're going to let t equal to 3x squared plus 2, right? Then we differentiate t, right? So it's t differentiating with respect to x. So we're going to get 3 2s are 6x. And what this will change to 0, right? So we're just going to get 6x. Now, if this is t, the function would be sine, remember this change to t, sine t, right? When we differentiate dy, now remember it's not x we have here is t, so it will be dy dt. But we have to differentiate this. The differential of sine is cos t, right? Now remember the chain rule, so I'm writing down the formula here. Dy dx is equal to dt dx times dy dt. Right? So we did this a couple of classes back. If you cannot remember, I suggest you look at that other video first, right? And then just come back to this. Alright, so dt dx is this here, just 6x. And dy dt is this here, cos t. So answer is 6x cos t. But you remember, the last step, we want to remove the t and put back what t was, right? So remember, t was this expression here, so we're going to write over this. I just put in the dot, right? So you know we times in. Instead of t, we're going to put 3x squared plus 2, put that in bracket. And that's it. We're finished. So I'm gonna just pause the video just to get a piece of paper to show you the shortcut way of going through this, right? Okay, so this is the same question, right? I just write it in a small piece of paper because I didn't leave space for the shortcut method. So this is shortcut method, we're doing the same thing, right? So when we do the shortcut of right, when we do the shortcuts of the chain rule, normally we would differentiate as normal, right? And then we would write down the differential of inside the bracket. So just take it slowly. Once you get through with the first two examples, you're gonna realize that it's easy, right? So let me just be able to for the first two examples. All right, so you're gonna actually get the answer in two steps. Okay, so what you're gonna do, you're gonna differentiate this here for me, right? What is the differential of this part in the brackets? So if I differentiate this, I get 3 2s are 6, x to the power 1. So 6x to the power 1, you can leave out the 1, right? So I just put in 6x. Good? Right. So that's it, right? We done deal with this. So we're going to treat this as sine, and we're going to ignore this bracket. We're going to pretend like it just had an x here. So we in our mind, we are thinking that it has a sine x here. Sine x, what's the differential of sine x? The differential of sine is cos. So I'm going to put on cos, but instead of x, I'm putting back this here. And that's it, we're finished. So I'm going to show you. This is the shortcut method. This is the long method. So we did all this working and then ended up with this answer, which is the same thing, right? So for the next example, we're going to do the shortcut method. I'm going to explain it back again slowly, right? So here's what we're doing. So dy dx. All right, let me just shift the book a little bit to make sure you see it. Okay, so first thing you do, you differentiate inside here, right? Inside this bracket. If we differentiate here, what we're going to get? We're going to get 7, right? Because this is going to change to 7, this is going to change to 0. So just 7 we get it. Good? What is the differential of cos? The differential of cos is negative sine. Right? Now, with that negative sign, be careful, right? Don't put the negative. Don't do that, right? Because it look like 7 take away, but remember it's times, right? Because if you look back here, right, it is times, right? So if you want, put the negative in front of the 7. Right? Because otherwise it look like 7 take away, right? Remember it was 7 multiplied by that take away. So just put the take away in front. Right? So differential of sine. Sorry, differential of cos is negative sine. And remember, instead is this, right? Sine this. That is what I was asking you to work with. And that's a shortcut. We done get the answer. Alright, so moving on to this one now. Now, if you want to go and do the long method, just to see if you get the same answer, no problem. Alright, but if you learn this, when it comes on multiple choice, you're going to get the answer like really quick. Alright, so we're going again. dy dx. So I told you guys 2 steps. No, it was 1 step we're getting it done. Alright. We're going to differentiate inside here. 5 by 3 is 15. X. Reducing this by 1, so we're going to get 2. This is going to change to 7. Right? Remember, I was saying, whatever you get here is your multiplying, right? So because this is a long expression, I'll use the brackets, right? Remember here was just a 7 now, so I didn't really have to use a bracket, right? Since it's so long, putting brackets to show that is all this be multiplied by the next part, right? Good. So I differentiated that, I put it here. I put the bracket because of how long it is, right? Sine, when we differentiate sine, we're going to get cos. And I have to put back my bracket part. Okay, so far so good. So I'm just gonna pause the video and write down 2 questions again, just to make sure that everything is okay. Okay, so we have this one here now, right? So same thing again, right? What I'm doing is just kind of making the questions look a little different, so you would know how to do it in every possible way that they come. Right? We're going to differentiate this here. We're going to get 4 3s are 12, x to the power 2, plus 2 2s are 4, x to the power 1. We can leave out that. Because of the length of this, we're going to put in a bracket, and then we're going to differentiate cos. The differential of cos is negative sine. Notice we put a negative in front here, negative sign, and you put back your brackets, right? And that's it, you're done. Okay, so for the trigonometry part of it, right? Besides these questions, there are also another way that we could use the sine rule. We could use the chain rule to work out these types of questions, right? There's a different format. If the question comes in a different format, okay? But it would be a little too much to do in this video, so we're just going to stick with this for now. We're going to get some practice with that, and then we're going to move on to that next type, as well as, you know, we would look at some product rule and some quotient rule, which involves trigs, right? So this is just to kind of get you started with some questions with trigs.